Struggling with slow database queries? In this video, we dive deep into SQL performance optimization, covering everything from identifying bottlenecks to advanced tuning techniques. Whether you're working with PostgreSQL, MySQL, or SQL Server, these best practices will help you optimize your database for better speed and efficiency. Identifying performance bottlenecks. The first step in addressing SQL performance issues is to identify the root cause. This involves understanding which queries or processes are slowing down the system. Monitor and analyze query performance. Utilize built-in database tools to monitor and log query execution times. Long-running or frequently executed queries are often the primary culprits of performance degradation. Identify queries that take excessive time to execute. Focus on queries that are run repeatedly, as they may have a cumulative performance impact. Examine system metrics. Monitor key database metrics, including CPU usage, memory consumption, disk I/O, and network latency. High resource usage often correlates with inefficient queries or poor database configurations. Profile database activity. Use profiling tools to capture real-time query performance data. This helps identify patterns and specific queries causing performance bottlenecks. Query optimization techniques. Poorly written SQL queries are a common cause of performance issues. Optimizing these queries can significantly improve database performance. Minimize data retrieval. Retrieve only the necessary data. Avoid fetching all columns or rows if only a subset is required. Limiting data reduces the amount of work the database needs to perform. Optimize query structure. Ensure queries are structured logically and efficiently. Simplify complex queries by breaking them into smaller, more manageable parts where appropriate. Reduce joins and subqueries. Although joins and subqueries are powerful, they can be computationally expensive. Minimize their use when possible and consider alternatives such as pre-aggregated tables or denormalization. Order of conditions. Place the most selective conditions, those that filter out the most data, at the beginning of the query to reduce the number of rows processed. Effective use of indexing. Indexes are essential for improving query performance, but they need to be carefully managed. Implement the right indexes. Identify the most commonly queried columns and create appropriate indexes to speed up data retrieval. Indexes are particularly useful for columns involved in search conditions, sorting, and joining operations. Maintain indexes regularly. Over time, indexes can become fragmented and less effective. Regularly rebuild or reorganize indexes to maintain their efficiency. Balance indexing. While indexes can dramatically improve read performance, they can slow down write operations such as insert, update, and delete. Avoid over-indexing and only create indexes where they deliver meaningful performance benefits. Data model optimization. A well-designed database schema is foundational to good performance. Normalize or denormalize. Normalize your schema to reduce data redundancy and ensure data integrity. However, for read-heavy workloads, consider denormalizing by creating additional tables to speed up data retrieval. Partition large tables. Split large tables into smaller, more manageable partitions to enhance performance. This reduces the amount of data scanned during queries and improves parallelism. Appropriate data types. Use data types that match your needs without over-allocating resources. Smaller data types consume less space and improve processing efficiency. Transaction management. Efficient transaction handling reduces locking, blocking, and contention issues. Minimize transaction scope. Keep transactions as short and focused as possible. Long-running transactions can lock resources, causing contention and reducing system responsiveness. Batch processing. For large data manipulations, break operations into smaller batches. This prevents locking large parts of the database and reduces memory consumption. Regular database maintenance. Routine maintenance is essential for sustaining optimal database performance over time. Update statistics. Databases rely on internal statistics to create efficient execution plans. Regularly updating these statistics ensures that the query optimizer has accurate information. Vacuuming and defragmentation. Remove obsolete data and defragment tables to improve performance. Fragmented data increases the amount of work the database engine must perform to access records. Archive historical data. Move older, less frequently accessed records to archive tables. This reduces the volume of data in active tables, improving query performance. Implementing caching strategies. Caching reduces the need to repeatedly execute expensive queries by storing results for quick retrieval. Application-level caching. Cache frequently accessed data at the application level to reduce database queries. Database-level caching. Some databases support built-in caching mechanisms to store query results temporarily. Enable this feature when appropriate. Materialized views. Use materialized views to pre-compute and store results of complex queries. This can be particularly useful for reporting and analytics workloads. Database configuration tuning. Optimizing database parameters ensures that system resources are used efficiently. Memory allocation. Tune memory settings, example, buffer sizes, to match your workload. Insufficient memory can lead to increased disk I/O, while excessive memory allocation can waste resources. Connection pooling. Use connection pools to manage and reuse database connections efficiently. This reduces the overhead of establishing new connections and improves concurrency. Parallel execution. Enable parallel query execution where supported to leverage multi-core CPUs for faster query processing. Ongoing monitoring and testing. Database performance optimization is an ongoing process that requires continuous attention. Benchmark performance. Regularly measure query performance and system metrics to identify new bottlenecks as your workload evolves. Test changes thoroughly. Before deploying schema changes or optimizations, test their impact in a controlled environment to prevent unexpected performance regressions. Automate alerts. Set up alerts to notify you when query times exceed acceptable thresholds or when resource usage spikes unexpectedly. Conclusion. Tackling SQL performance issues requires a holistic approach that spans query optimization, indexing, data modeling, transaction management, and system tuning. By continuously monitoring your database and proactively optimizing its performance, you can maintain fast, reliable access to data while scaling to meet growing demands. Would you like a checklist for SQL optimization or guidance on a specific database system? Don't forget to like, subscribe, and hit the bell icon to stay updated with more database optimization tips.